Hi, everybody. Welcome to our version of Virtual Night Sky for tonight, November 3rd. We're getting towards the end of 2021. I can't believe it's November. I don't know if things are moving as fast for you as it is for us at school. We've only got about 4 weeks of actual classes left, and then a week of finals, and then we're off to Christmas break and the winter break, getting ready for the next semester. So things are moving really, really fast. Got a lot of projects going on, and we've been especially focusing just recently on a very special project about the James Webb Space Telescope. So tonight's program, I'll introduce sort of just what we're going to talk about and then kind of introduce the players and how this is going to work. But tonight we're going to have the first half presentation on the James Webb Space Telescope, which is going to launch on December the 18th. You'll learn a bit about what it is, why it is, what kind of science it's going to provide for us, and how ASU is connected to that amazing project. So that'll be the first thing. The next part will be, I'm going to be presenting to you some views of the night sky, but in particular, a beautiful story that takes place in the eastern part of the sky right now. Just to tease you a little bit, this is about the sacrifice of Andromeda and the rescue by Perseus, and we'll cover that in the 15 to 20 minutes after the James Webb presentation. And then, as you know, if you've followed us, and you've seen these before, we've got some things, just some current events that are going on. We'll get you up to date on what's happening in space and in science right now. And most importantly, some resources. So after the program, you'll have some tools that you can look into and find out even more about what we're talking about tonight, and look for that in the future. My team and the people that help put this together, I guess I'd say our team, it's not led by anybody necessarily, is part of a community outreach group that is stationed at the School of Earth and Space Exploration at ASU. And I'm your host tonight. My name is Rick Allen. Your webmaster is Kim Baptista. You've probably seen emails from her. She's the one that's getting this thing organized, getting it launched, getting it organized, letting people register and come to the table. So thank you, Kim, for that. My longtime colleague and friend is Meg Hufford. She's been with me in community outreach in that amazing building that's behind me right there on the Tempe campus, and she's here with us tonight. You have also seen some other players. They're carrying forward. Alicia Hyatt is now a staff member with us, an education research specialist, and she'll be on the team. You'll hear from her tonight. And then Alex Blanche is actually playing two roles. He actually is involved in the James Webb Telescope, so you'll hear from him and the work he's doing on that. But he also is a player and helping to facilitate the program tonight. He'll be working with questions in the background, and you'll hear from him later, not only about the telescope, but about other things. Just some technical things. We like to do closed captions on our thing. It just is easier for some people, and it's easier for us to provide those through recording. If you don't like them, you're in control. So if the closed captioning is happening and you don't want to see it, you can just disable it on your own computer. Don't worry, that won't disable it for anybody else. Use there's a drop down at the top of your screen that will allow you to fit to screen. That's really the best way to see us. So you'll see presentations on the main part of the screen, and then a little side window where you'll get a little view of people like me as we present. The other thing is we disabled the chat, so there's no way just to sort of like just chat with us, but you are not only enabled, but encouraged to ask questions. So at the bottom of your screen also, there's a question and answer button. And if you push that button, you can just type in anything you want about sort of our program tonight. Think about it as it's moving along, as you're hearing something, you want to sort of like put a little question in there, and go ahead and do that. And what we'll do is we'll try to capture a lot of questions while we're talking. Some of them are easy, and we'll just sort of get right back to you, and sort of you'll see that they magically get answered. Others we will hold for public comment at the end of the sections of the program and the presentations. So just when the spirit strikes you, make sure you're ready for that and enable that. That's a good way for you to interact and for us to talk to you as well. The other thing, just before I sort of like start introducing the team that is going to be joining us and delivering the information on the James Webb Telescope, we have two special guests tonight. I'm just going to launch a quick little poll. It's another way for you to interact with us, and this will help us kind of get started here. So you'll see the poll kind of show up on your screen here, whether you don't know it or not yet. Oh, you see some people people are actually operating it. This is a way for us to sort of like get an idea about, kind of what you're walking into this with. You know a lot about the James Webb Space Telescope. Is this something that just kind of new to you? And so that kind of helps us understand what our who's in our audience and where we're at and what we need to work on. That sounds about right. So it looks like about half of you are fairly familiar with this, either because you've watched other programs that we've done in the last several weeks, or because you're just savvy that way, sort of keeping an eye on science and what's going on in space. It looks like the poll is kind of coming to a little bit of an end. So Tim Carlton and Rosalie O'Brien are with us tonight, and they're going to be joined by your very familiar face, Alex Blanche. The three of them are going to take the next 25, 30 minutes or so and give us a really, really nice in-depth overview of the James Webb Space Telescope, where it came from, what it's going to do, why we are so excited about it, and how it kind of relates to ASU and goes along. So please just, you can lose that poll off your screen now. And please welcome to the screen with me, Tim Carlton and Rosalie O'Brien and Alex Blanche. I'll let you guys take over the program, and I'll be back with you as soon as they're finished.
All right. Thank you, Rick. Thank you for that great introduction. So as Rick said, my name is Tim Carlton. I'm a postdoc here at the School of Earth and Space Exploration. I'm really interested in galaxies and how they evolve and how they kind of change and how we can kind of see a lot of different types of galaxies that we see today. And so I'll just kind of start off our program here with a little bit about just some background about the James Webb Space Telescope and what it is and why, like Rick said, why we're so excited, but also just kind of a lot of the motivation why we wanted to kind of build this cool thing and what it can do. So here, just kind of to start off, I have an image of the James Webb Space Telescope if you have not seen it before. And this is probably different than a lot of telescopes that you've seen, but it's a large telescope that's going to be launched out into space by the end of this year. And we'll study a lot of cool objects, both in our solar system all the way to the edge of the universe, and specializing in infrared light. So I will just kind of, go through a little bit about JWST and why we want to build it. So first, I'll just note, like, you can see here really the scale of the JWST. Is the biggest space telescope ever built. It'll be the biggest one ever launched into orbit. And you can really see how large it is. The primary mirror here is 6 meters or 24 feet across. And this is really kind of the most advanced telescope we've ever built. So I just kind of want to talk a little bit about why we're building this particular telescope and why we're so excited about it. And to do that, I want to reach back just a little bit and talk about the Hubble Space Telescope. This is probably something a lot of you are familiar with as well. This is the James Webb Space Telescope is kind of described as the successor to the Hubble Space Telescope, because the Hubble Space Telescope has been doing some really amazing science for the past 30 years or so. And like I said, it launched back in 1990, and it was the most advanced, I kind of put here space telescope, but really just the most advanced telescope at the time, where it had kind of the best available detectors, and it had really precise optics, and kind of being out in space, it was able to really kind of pushed the new frontier in terms of what we could see outside in the night sky. And in particular, I wanted to kind of highlight, this is one of the earliest images that the Hubble Space Telescope took, and it really kind of highlights how much is it improved over kind of the existing kind of best technology over the time. Where you see here on the left is a ground-based image of a pair of stars that are really close together on the sky. You can see they kind of blend together, and you can kind of see the stars, but you don't really see anything else. And then on the right, you see the image of the same object taken with HST, where it had dramatically improved resolution, where it was able to kind of make the image a lot more fine, and you could kind of separate all the different stars. And then it was also a lot more sensitive. You can see a lot more of the background objects and see a lot fainter than you could any other way at the time. And so kind of with this really amazing technology, I was able to take lots of really interesting pictures here, like we have the Hubble Ultra Deep Field, we have kind of some nearby really interesting galaxies, and kind of amazing nebula. So kind of by looking at this, kind of looking at how much better HST did compared with the existing technology of the time, it kind of gives us a sense of, all right, we're building this kind of best new telescope, and it kind of allows us to imagine how much of a jump forward it will be once it's launched. Right, so I also want to kind of highlight this image for you. So this is the Pillars of Creation. It's a star-forming region in kind of nearby in the galaxy. And one thing you can see is that looking at it, we have kind of two different images here. The image on the left is taken with normal optical light that you kind of are familiar with seeing with your naked eye. And the image on the right was taken with HST using its infrared camera. Now, HST has some infrared capabilities, but it's not kind of its specialty. But you can already see, even with HST's infrared capabilities, you can really get a whole new view of this object. You can see kind of a lot of the stars behind the dust, and you can really get a new enhanced view of this particular region. And so that's kind of, as people realize how great this infrared imaging was starting to be, that kind of gave them motivation to really, people started to get really excited about this infrared imaging. It can tell us a lot about like star-forming regions and really distant galaxies and disks. Basically, a lot of things that kind of look red for our optical light, you can see a lot more detail by looking in infrared light. And there are some existing cameras, telescopes, kind of both on the ground and in space, that can look at this infrared light, but they're really not as sensitive, or they don't have really as high of a resolution. And so it's a lot harder to kind of get down into a lot of those amazing details that we can have to better understand those types of objects. And so that is ultimately what motivated the James Webb Space Telescope, that desire to kind of get a better sense of what's happening in infrared view of galaxies. And so here it just kind of is this is just kind of showing how big the mirror of JWST is compared with even the Hubble Space Telescope mirror. And it's really a lot bigger. And that's basically what you need to really get a lot of the improved resolution and sensitivity looking at these infrared objects. And so that's, and so that's kind of the motivation for we're building JWST to get as good of a view of the universe in the infrared as Hubble gave us in the optical. So I just kind of also want to touch on how this connects with ASU. And in particular, I'll highlight here, this is the science working group of the James Webb Space Telescope, a group of scientists that advise on kind of what types of science JWST should be looking at. And down here, kind of on the second from the left on the bottom row, you see Roger Windhorst, professor here at CC, who are all Rosalia and Alex and I are working with. And because he's part of this working group, he has guaranteed some of the first observations with JWST. And so that's really exciting as we're looking forward to the launch and seeing some of the first images. And so with that, I'll just leave this image here, and I'll have Rosalia talk a little bit more about some of the exciting science that we're looking to do with JWST.
Hey, yeah, thanks, Tim. Let me go ahead and share my screen. So, hi, I'm Rosalia. I'm a second-year astrophysics PhD student. I'm working for both Professor Roger Windhorst, with which Tim just mentioned, and then also Dr. Rolf Janssen on a couple projects here at ASU, which just so happens James Webb will provide a lot of really important and interesting information in just the stuff I'm doing here at ASU. So yeah, I kind of want to give you guys a little idea of the kind of research we can do with James Webb. So to start, I'm going to throw up this Hubble Ultra Deep Field image. This is a really famous image that was taken with Hubble in 2014 because it just shows really a crazy amount of galaxies. And it's seeing galaxies that are farther away than we had ever seen before Hubble had taken this photo. Most astronomers use photos like these to study the actual galaxies. So I circled some of the bigger galaxies in this photo. But that's not the only interesting thing that we can study in these Hubble images. It just so happens that in these areas in this image that look black, Hubble is still receiving light in those areas. So Hubble, the detector on Hubble is still getting photons. Some of the light in these blacky areas is called extragalactic background light, where extragalactic means it's light that's coming from outside of our Milky Way, so outside of our galaxy, and background means that this light is coming from behind the galaxies you see in this image. Again, pretty much everything you see in the image you're looking at here is a galaxy with just one star in the bottom right quadrant. Something that's interesting about extragalactic background light is it hasn't been studied very much. So astronomers don't understand where all of extragalactic background light is coming from. And some people here at ASU, including myself, are interested in studying this farther. To kind of highlight this discrepancy we're seeing, here I have a figure kind of displaying a rough drawing of the amount of extragalactic background light we are currently detecting with Hubble in pink. And then in that green-blue color, that's the amount of extragalactic background light we expect to see just based on everything we know about the universe. So when we first measure extragalactic background light, we expect to see the blue curve, but we're currently seeing the pink curve. So there's a clear gap. We're detecting more light than we think should exist, which pretty much means that there's something we don't understand about our universe that I guess we're trying here at ASU to explore further. How will James Webb help with this? So as Tim kind of touched on, James Webb is going to see farther away than we've ever seen before. So Hubble was already seeing farther than we had ever seen up until Hubble, seeing galaxies really close to the beginning of the universe. James Webb is hopefully going to see the very first stars and galaxies because it's going to be able to see so far away. And so we're going to see galaxies that we can't really see with Hubble with James Webb, which is part of the reason that it's so exciting. So if we look at this same Hubble Ultra Deep Field image, if we look at the same region of the sky with James Webb, we might see something like this, where we're seeing galaxies that are really far away that we couldn't see with Hubble, but now we can see them with James Webb. This can help us understand where extragalactic background light is coming from, because we will now see galaxies in these regions that before were dark, but now we're seeing galaxies there. To be more specific, if James Webb happens to see more galaxies in these red circled regions than we're currently predicting should be there, that could help explain the gap we're seeing in extragalactic background light levels. The project that this whole research is a part of is called SkySurf. It's led by Professor Windhorst, but a bunch of us here at ASU are a part of it, including Tim and I and Alex. And we also have a bunch of undergrads. We've had some high schoolers working on it in the past, and yeah, it's been a really great time. But this isn't the only thing we can study with James Webb. What else can we do with James Webb? So it just so happens, and Tim also talked about this, James Webb, since it will be seeing a different type of light, so Hubble is usually going to see optical light, so that's going to be light you can think of as a wave. So optical light is going to be smaller or shorter. It's going to have shorter wavelengths than what James Webb will see. So if we look at this figure here, you see the top row is infrared and the bottom row is optical. So the top row has the longest wavelengths and the bottom row has the shortest wavelengths. Hubble can mostly see in the optical and the near infrared. So here we have 4 pictures of the Milky Way at different wavelengths. What Hubble sees when it looks at the Milky Way, which is our galaxy, it sees the bottom 2 rows. What James Webb will see if it looks at the Milky Way galaxy will be something more like the top 3 rows. And as you can see, each row looks really different from the other. In the top rows, you're seeing some, like dust and gas that you can't even see in the optical, which can tell us a lot about what's going on inside the Milky Way. You can kind of extrapolate this idea to other galaxies. So when we look at other galaxies with James Webb, we're going to see stuff within these galaxies that we can't even see with Hubble, and that can tell us a lot about what's going on within these galaxies. The project that this science is a part of is a project I'm also involved with called Treasure Hunt. This is led by Dr. Rolf Janssen, who's also here at ASU, and collaborators include me and, again, lots of other people. For Treasure Hunt, what we're doing pretty much is looking at a specific area of the sky with Hubble, and then James Webb is going to follow up and look at that exact same area of the sky with James Webb. And then the galaxies in that field, we're going to be able to paint a full picture of what's going on, because we're going to see the Hubble data in the optical and then the James Webb data in the infrared. Something else that's interesting about this project, which I listed here in this bottom bullet point, is that we can also study time variable objects in this field with James Webb. So this includes supernova or brown dwarfs. So these are just going to be things where, for example, if you look at a certain region in the sky at one point and then sometime later look at it again and you see a bright flash that wasn't there before, that could be a supernova, and that could be really interesting to study. Of course, SkySurf and Treasure Hunt just happen to be the 2 projects I'm involved with here at ASU, but these barely scrape the surface of all the things that can be studied with JWST. I'm mostly interested in extragalactic astronomy and cosmology, But James Webb will also be really great for studying things like exoplanets, which I think a lot of people are really interested in as well. Yeah, and with that, I think I'll give it over to Alex.
All right, thanks, Rosalia. Hi, everyone. My name's Alex. I hope if you're a returning audience member, you recognize me. I'm usually part of the student team. But additionally, I'm actually a researching student, and so I get to actually do some research involving Hubble and hopefully now in the future James Webb. And so I get to talk a little bit about that. What I get to do is I get to study, generally, I get to study escaping radiation from galaxies. The special thing about this radiation is that it has shaped the way our universe is today. And so the specific kind of radiation that I'm talking about is called Lyman continuum photons. You don't have to know what those are. There's not going to be a quiz. You don't have to remember it. But basically, these are wavelengths of light that are high enough energy to ionize hydrogen. And so you can kind of see here. And that just means that hydrogen is normally a proton, an electron, and this radiation kind of kicks that electron out, and then you just have that proton. And so we have a lot of hydrogen in between the spaces in our galaxies. You can actually kind of see this web behind us. These kind of dark patches are the light streaks are where galaxies kind of clump together because of gravity. But in between, we have a lot of hydrogen, and all of it's ionized. And so we don't understand what caused all this hydrogen to be ionized. And so what I get to study is how this escaping radiation from galaxies might have affected that and why our universe is the way it is today. But more specifically, what is the connection between James Webb and Hubble and this research? So the thing is, Hubble and James Webb and really any telescope, I like to think of it as kind of a view back into the past. And that's because with the limited speed of light, and the speed of light being the fastest thing in the universe, is when we're looking back at these galaxies, we're seeing the light from, so if you have a galaxy a light year away, you're seeing light from 1 year ago, because that light has to travel 1 light year and then to reach us, and that's 1 year it actually has to travel. So when we're looking at really distant galaxies that are billions of light years away, we're actually viewing their light billions of years in the past. So looking through telescopes like Hubble and James Webb gives us a view into our very early universe and gives us a better understanding of what our galaxies were doing, what stars were doing, and how our universe was forming. And that includes the ionizing of all this hydrogen I was talking about. So specifically right now, we're using Hubble to look at these distant galaxies and better understand what they were doing a long time ago and how that affected to where we are now and what our universe looks like today. But the difference between Hubble and what James Webb will be able to do is, well, James Webb, as we've Tim and Rosalia both been talking about, it has different capabilities, and so it really gets to look farther, and you can kind of see that here. This is a graphic of the history of our universe. Over here on the left is the Big Bang. This is kind of the beginning of the universe, and then you have the first particles form, and then first stars, and then galaxies, and then you have galaxy evolution, and then here we are today. Well, Hubble actually has been able to view up till about 1 billion years past the Big Bang. But James Webb will be able to look farther than that, into the hundreds of millions of years after the Big Bang. So this is really when we start to see, the first stars and galaxies, and even before that. So it's a really exciting era. And because so many, or there have been a lot of theories based on the fact that ionization and this ionization of the hydrogen came from some of these first stars and black holes and these first very vicious kind of centrally forming galaxies. James Webb might be able to study those better and how they got to that point and better understand that galaxy process in addition to just how our universe came to be. So James Webb is able to look farther in terms of seeing farther galaxies and seeing dimmer galaxies, but it's also able to look further in the past and learn more about our early universe than Hubble was and other telescopes. And so that's really exciting. And also because a lot of this early galactic light that we're getting isn't visible by Hubble anymore because it's not in visible wavelength anymore. It's in the infrared. So JWST will be able to see farther and be able to see more dim galaxies and be able to get a better understanding of what our universe was like back then. And so here's another timeline and a different kind of marking of what's really going on. You can see here, this is reionization. That's when all that hydrogen was starting to get ionized. So you can see the first kind of stars and galaxies start to kind of form around here, and then they start ionizing. And that's kind of the theory of what happened. And so that's what we've been studying. And so Hubble can kind of see around here. So we can study kind of right after that happened, right after those galaxies had kind of ionized all that hydrogen. but we're still kind of in a state where we can figure out what they have been doing before that. But hopefully James Webb will be able to give us a better understanding of this point right here, where it was actually reionizing, and get a better understanding of how that universe changed. So hopefully with James Webb, it'll be able to further not only just our general understanding of the universe as a whole and all the other research that's been going on, and exoplanets and all the numerous amounts of science data that it can contribute, but hopefully more specifically this as well, because this is what I've been interested in, and this is what I've been researching. I do want to mention that in addition to this is the research I've been doing at ASU, in addition to Roger Windhorst's group, this is actually a lot of my research has been partnered with the Arizona ASU NASA Space Grant. And this is a student program. This is a program for students that's offered at an undergraduate and a graduate level, where NASA grants money and funding to promote student research. So I'm actually a student researcher, so I get paid to do research. I'm partnered with a mentor, and there's a lot of educational outreach, and this entire program is a very streamlined way for students to get involved with research, get a mentor to help them with it, and not just kind of kick them out on their own, but also, get paid for it, which, as much as I'd say I would do this for free, getting paid for it's very nice too. But it just gives a very good streamlined process for all this. And I do want to recognize that a lot of the research I have done has been in partner with that. I'm currently in my second year, but James Webb, Hubble, we're looking at the past, and now we're going to look further and hopefully get a greater understanding of our universe and reionization too, and maybe get a better understanding of that. So that's kind of my talk. I think probably what we'll go down is I think we're going to go to Rick and Alicia, and they have some questions from the audience that you guys will get to ask, and we'll answer.
Sounds great. Thank you guys very, very much. I have to tell you that I get to go to work every day, and that's just fun in and of itself. But to be able to work with these students and postdocs and people that are just these amazing people working on these really, really important projects, I just think that's amazing. And Alex, did you say Lyman continuum radiation? Is that what you said?
Yeah, so Lyman continuum photons. It's kind of a mouthful.
Okay, yeah, I love it.
Yeah.
I never heard the term before. Oh, well, yeah. Good for you. I think it's super. So Alicia, how you doing tonight?
Great. How about everyone?
It looks like we've got tons and tons of questions. So let's see if we can go kind of fast, but we'll try to capture a bunch of these, and we might have to answer some of them offline.
Absolutely. All right. So Sarah wants to know, when do we expect the first pictures to come back from the James Webb telescope after it's launched into space?
That's a great question. And so I can kind of share this really quickly, just kind of share this website that if you could look at jwc.nasa.gov/content about orbit, it has a really detailed timeline of like everything that's going to happen from kind of the course corrections to where it's going, to the sun shield deployment. And it talks about kind of in the after the first month or so, they'll start taking some test images, like making sure that everything's aligned and everything's working. And then after around 6 months or so, we'll start to get some of the first real science images that we'll be able to look at and study. And so that's exciting.
What I found amazing was I've been learning about this, and I've been attending all kinds of those seminars and things about James Webb. And really within 6 months, I mean, really from launch, just before Christmas to halfway through the year, it's going to get up there, it's going to deploy, it's going to get commissioned, all things are going to get aligned, and it will start actually sort of like telling us just how effective it's going to be and what it's going to do within a very, very short time period. And it has to travel a long way to get to its home, about whatever it was, 3 or 4 times the distance to the moon. So I think that's an amazing schedule, and I haven't seen it written out like this, but yes, it's so I guess the answer is way quicker than I would have ever believed. We're actually going to start to see this thing start to produce its technology, and then we will start to see science really very quickly in the process. So that's very cool.
Wonderful. Awesome. Our next question looks like it's from Michael. And what is the point of, or Michael asks, what is the point of dividing the primary mirror into several hexagonal mirrors versus one single mirror? So maybe someone would elaborate on that a little bit more for us.
Yeah, I mean, I can, I think, just briefly touch on that. It's really just kind of, it helps with, it's a little easier to fabricate than a round mirror, just kind of breaking it up into all these different pieces that can kind of be fit together. I'll just also kind of plug the Arizona. This is a technology that was pioneered here in Arizona decades ago. If you've heard of the multiple mirror telescope, they were the first people to, rather than build a telescope with one giant mirror, they said, okay, it's a lot easier to make 10 different mirrors and align them just the right way, and you get a lot bigger mirror compared with a lot easier than trying to build this big mirror in one piece.
There's also a little bit of practicality of just getting it into space, right? There's the payload, the cabinet that it goes into when it gets into a rocket. It would not support a 25-foot mirror. So not only is it segmented, and for all the reasons Tim talked about, but it also has to fold. And so there's this really amazing, elaborate unfolding and deployment of the spacecraft once it gets into space, and including those big Mylar panels and all of that. So it's a good question.
So this next question, we have a couple of different, written a couple of different ways, but basically what the audience is really wanting to know is what if JWST takes even more extragalactic background light than the Hubble Space Telescope is currently taking?
Hi, so I can probably answer this. So I actually haven't thought about this before. I think right now we're not expecting James Webb to detect more extragalactic background light. But if it did, I guess the fact that we're not expecting it to detect more extragalactic background light right now means that if we did detect more, that would pretty much farther mean that there's something we really don't understand. The easiest answer would probably be that there's just more galaxies than we think there should be, or there could be, for example, a lot of really diffuse or small galaxies that we can't really see with Hubble or James Webb, but we're still getting their light. That could also raise extragalactic background light levels. But yeah, that's a really interesting question to think about.
As you were doing your presentation, Rosalie, I really loved the way you structured that and put that together. But it's the thing about science is you go up there with an expectation, and then the real magic happens when it's not what you expected. Just like you were describing, these little areas, these little pockets of supposed dark where we're actually finding there's light that can't be quantified, can't be identified. That's a surprise. And then that triggers the science. That triggers somebody to say, okay, we didn't expect that. We can't explain offhand what's doing that. And so now new technology gets deployed. We get to look into that certain thing. And so I guess, when we kind of talk about what would be the best thing that James Webb could do is not to confirm anything we already know, but to show us essentially, kind of what's that next thing, what's even further, what's kind of answer our questions, but also send us further into the exploration. So that's really cool. Good question.
Yeah, I think that's like one of the really exciting things about James Webb is we're going to see things that we haven't seen before. So although we kind of like what Rick just said, even though we expect one thing, there's no promises that we're going to see that. So it'll be very exciting.
I love the way science works.
I think that's it from the peanut gallery on my end, but I will pass it over to Rick. Thank you so much to our wonderful panel for
Alicia, while I get ready, I think we had another poll or two. Why don't you just launch those real quick?
Oh, yes.
And I really want to thank Alex and Tim and Rosalia. It's a really great, concise explanation of what you're, and we can tell from the way you're describing this and your passion about this that you're obviously in this thing really in a big way. This is your interest, your research, and Webb is going to kind of pay off for you big time, I hope. So this will be really great. Thank you guys for your presentation, for sure.
Thank
you.
Yeah, so how many people remembered this?
So we went ahead and launched a poll. Do you remember the Hubble Space Telescope launch in 1990? You have two choices, yes or no.
Yeah.
And go ahead and cast your votes below.
We were talking about this before the show, and several people here weren't even born yet, but that's all right. And you guys, you might remember, we didn't mention it, but when Hubble launched, it was actually not optically aligned correctly. Remember that part? That would have been a good poll question. It got up there and had a disappointing start because they sort of like misaligned a couple of components. But Hubble was always intended to be serviceable. So a service mission was organized, it went up there, put in new equipment, and then it just became the amazing telescope that it is. James Webb is different. It's actually going to a place where we can't get to. And so it won't be serviceable, so we'll do that. But anyway, 1990 to now, what's that, 31 years later, here we go, and the next one coming, and pretty excited about this.
So
one more?
67% of us do remember it, and 33% of us.
Exactly, 2/3, 1/3. How does that happen? That's pretty amazing.
Easy. All right, launching our next and our last poll. Do you plan on watching the James Webb Space Telescope launch? Yes or no?
And have we been explicit? So we now think this is going to be December the 18th. That's its schedule. And Kim and I were talking about this today. We sort of forgot whether we have to factor in the daylight savings time or not, but it's really, really early in the morning. So we're thinking between 5 and 5:30. You'll hear about it. I mean, this is going to be a big deal. You'll start to hear it in the news more and more and more as we get into December. So the key thing is right now projected December 18th. We will be doing some programming in and about that, and some of his principals, including Roger Windhorst, everybody sort of like be available. Actually, Roger, I guess, is going to the launch site, isn't he? But we will we'll do some work to make sure that you guys can enjoy this and watch it and see it launch. These things get pushed every once in a while, but right now this is the target. It's there. It's getting mounted into the rocket. It's getting prepared for launch. We expect that to happen. So it'll be very, very cool.
It looks like 89% of us are super excited for launch and are looking in our inboxes for Kim's emails on instructions. So that being said, I'm going to end the poll and pass it back to Rick.
It's currently saying 7:20 a.m. Eastern Standard Time.
So that's 4:20. Or no, actually, no. By that time, it's 2 hours. Okay, so 5:20. I think we're right. So 5:20 in the morning, December 18th. We'll all be there with hot coffee and donuts, and I'm not there. I will be on campus at the Marston Theater, sort of broadcasting from there. So good. Well, very exciting. We have a couple more James Webb sort of oriented discussions and events coming up in the near future. I'm going to tell you about that before we close the show tonight, just things to look forward to, sort of what we're doing. But I just wanted to spend at least a little time. It's sort of one of the things that is a passion of mine is to just make sure that we, kind of keep you up to date on all this amazing space science, right? All of that stuff for sure. But we also want to, I'm just trying to launch a little thing here real quick while we're waiting. We also want to kind of just keep you looking at the night sky, your night sky, the night sky that you get to see from your neighborhood and all of that stuff. So I was going to spend a bit of time. I'm going to just spend about 5-10 minutes here talking about a region of the sky and this really beautiful story that is playing out. It involves 6 different constellations. And so just to orient a little bit, the big, huge blue dot you see in the middle of your screen is everything that is above the horizon at 8 o'clock tonight. So we will come to a close here in about 15 minutes. And theoretically, if you went out in the night sky and looked up and you had a perfectly clear night sky, right, not necessarily in the big city lights and all that stuff, you would have a horizon completely surrounding you in all directions. And above that horizon would be a number of stars. And you can see here some things going on. I guess you likely can see these planets, Saturn, Jupiter, Neptune is not visible to the naked eye, but it's up. Uranus is down here. If we were to sort of look just up the top of the screen here, Venus is already set, or it's just on the horizon right there. And so this is the line of the ecliptic. This is the parade of planets and the constellations that they're moving through: Sagittarius, Capricorn, Aquarius, Pisces, Aries, and Taurus. These are the sort of signs of the zodiac. This is that area. What I wanted to focus on is actually kind of more towards the east. It intersects the zodiac just a little bit, but I'm kind of orienting ourselves. So now the eastern horizon is the green part. Everything below the green part is below the horizon. You can't see it. Those things will be coming up very soon. So you see horizon, or I'm sorry, Orion, right below the little symbol for east right there. That means it's below the horizon, but in a couple hours it will be here and it'll be visible. What I wanted to show you is a bunch of stuff going on. This constellation, this one, the big square right here, these two lines that trail down this way, and this is a sort of big sort of rambling constellation here. Those are all the story of Andromeda, and Andromeda being sacrificed to a sea monster and her rescue by Perseus, and all of it plays out. So if you'll indulge me a little bit, I'm just going to kind of do a quick little screenshot, and I'm going to start drawing on the screen here. So right up here is a constellation called Cephus. It is not very far from the North Star. So that's Polaris right there. And so it's kind of, if you're looking east, it's going to be way over towards the north. I always thought when I was a kid, it sort of looked like an upside down house or a church, right? Sort of over there. And Cephus is the king. He is the king of Ethiopia. His wife, you have undoubtedly heard of this before, is a constellation called Cassiopeia. You sort of know it as a W in the sky. I'm going to erase that so I can make it a little bit more detail. It's kind of like a little W shape in the sky, an M, I guess, if you're looking the other way. And it's fairly easy to find. It's opposite of the North Star than the Big Dipper, so you'll sort of see it. Big Dipper will be on the other side. When the Big Dipper is down, Cassiopeia is up, and the opposite happens. They go around like a circle. Perseus is this little trail of stars down here. And so he's a player in the program, and we'll kind of get to that in a little bit. These little stars, trails that come down off of this corner of the great square, is a constellation called Andromeda. Andromeda is also connected to the great square, and it is also happens to be Pegasus, the horse. And you can see his front legs going up this way, front legs going up this way, and these stars sort of make up the back end. Down here is the sea monster. The constellation is called Cephus, and it is a gnarly sea monster with big, huge, sharp teeth, and it sort of plays into the story. So let me just kind of walk you through this a little bit. I'm going to kind of clear this and restart because I want to show you some science going on in the background as well. In order to sort of see this, I think the ones that are easiest to find are going to be that great square. This part of Pegasus, you should see it. It's directly over the eastern horizon. It's very high in the sky right now when you go out. But the thing to key in on, the thing that's easiest to see is probably Cassiopeia. And Cassiopeia, as I said before, looks like a W, but I want to show you something about Cassiopeia that I think is kind of interesting. It's made up of 5 stars that kind of, shape, oops, I got the eraser on, not the pen. The 5 stars that make it up are here, 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 and here. But this one is actually a fascinating star for me. It's not the brightest, not by any means. It is actually the 6th brightest star in the constellation. It's called Eta Cassiopeia, and it is actually the same size, the same luminosity, the same mass, the same color temperature as your sun. Now, we've been talking about great distances with the Hubble Space Telescope and the James Webb Telescope. This is only 20 light years away, if that's only. It takes light from that little star 20 years to get to you. But it is exactly what your sun would look like if you were there. So if you had a chance to take a vacation and go out to Eta Cassiopeia, turn around and look back, you would see a vast array of very, very bright stars in the sky, and one just sort of like the innocuous star that doesn't look like much. It's kind of a hanger-on to a part of another constellation, a little tiny dim star hanging out there, not calling much attention to himself. that would be your sun. And so I've always thought that was really fascinating. I can tell right now that this particular part of the program is going to go a little long. So I'm going to start this journey, give you some things to look at tonight, and then in 2 weeks, we'll pick this up again, sort of like finish what we started here. To talk about a little bit of science in the Cephus. Remember, I had a thing that sort of looked like a bit of like an upside down church steeple or whatever here. I want to call your attention to this little area right here. There's a little tiny triangle of stars right there. This one and this one and this one. This one down here, the last one I showed you, is called Delta Cephe. And Delta Cephe is one of the most important stars in the sky and in science. And here's what happens. It's a variable star. And so it dims a little bit, it grows a little bit, it dims a little bit, it grows a little bit, and it does it over a fairly short period, only a matter of days to a week. And you can actually see this in a good clear sky. If you get a look at this, maybe not in the city of Phoenix, but certainly in the outlying areas like Fountain Hills, Ahwatukee, and all those places, you can see that sometimes it's as bright as this one here. Other times, it's as dim as this one here, and it's slightly different dims, and you can sort of watch that happen. Here's what we found out, is that the pulsating of these stars relates to their luminosity. So the timing of that pulse tells us how bright it is, where it is. And so Delta Cephes became the best type star ever to help us understand distances. Because if we can identify that type of object, in our galaxy, in other galaxies, in other places, we know how bright it is because it's sending us the signal that tells us that. If you know how bright it is there, and you know how bright it is in your telescope, you can tell the distance to that star. So if you ever wonder how we sort of know something is 20 light years away, something is 500 light years away, something is all that, there's very, very little announcement going on that tells us that directly through telescope, but it is tools like this particular variable star in an ancient constellation associated with the king and queen of Ethiopia. They kind of tell us what's going on there. And so I love the fact that the night sky is observable. We can learn about it. You can go see it. And sort of it's challenging these days with all the light pollution and the stuff going on in the sky. But it's something we can spend some time with, and it's something we can look at. And then if you dig a little bit deeper, you start to understand there's some of these other properties going on. These constellations are delivering to us some really interesting and intriguing sciences, and the history of the science of astronomy comes out of these objects as we look at them. Okay, so that's how we sort of like sorted out our time tonight. I would love to spend, let's kind of get back to this 2 weeks from now. Let's spend that particular more time during that hour just playing out this entire story. Let's bring in all of these other constellations, talk a little bit more science. There's a major galaxy hidden in that system. There's two more variable stars that tell us something, two very, very, very different things about their origin and where they are. And we'll have to put that off until next week, okay? So I'm going to kind of wrap up this particular part of the program. We can take some more questions if you want. I'm going to just kind of move towards back. I'm going to hand the microphone back to Alicia. We've got a handful of really interesting and diverse current events that are going on. What this is the section of the show that I'd sort of like to hear something going on the news. You sort of see something coming, you hear something that happened, and this is a chance for you to sort of like get to hear what these things are and what's going on. So we're going to call this current events. I'm going to turn it over to Alicia. Thank you. I will stop sharing.
Rick, thank you so much. I'm going to go ahead and start sharing my screen. Alrighty, and then I'm going to try and minimize all this, get some stuff out of the way. Alrighty, so in this week's current events, we're going to talk about a past event super quickly. Hopefully you remember a few weeks ago, we had the Deputy Director of Interplanetary Initiative, Jessica Rousset, and she came and spoke to us about her department and all that is going on over there. But what she didn't mention is something that ASU just announced, excuse me, and that is that ASU and Blue Origin are coming together to create a business park in orbit. So what's really exciting about this is that this pioneering station will make its home in a low Earth orbit and offer the infrastructure to support new markets in space, including research, manufacturing, travel, education, and exploration. And so this is very exciting because it is not a limiting program. It's very inclusive. And its goal is to showcase that this is our moment to bring space to everyone. So that is a very interesting note, and we will make sure to put that in the chat, or a link to this in the chat as well as in our emails. And so an exciting news happening tonight, if you live north of Arizona, which some of our audience members do, you might be able to see an aurora tonight. So you can see over here in these colored zones where depending on where you live, you might be able to see one. Well, why is this happening? Well, exciting news. Our beautiful sun is producing what's called a coronal mass ejection. And this is a really fancy term for basically a large bubble of gas and magnetic field that gets shot into space. But what's so rare right now is that the sun could shoot it anywhere, but it's shooting it towards the Earth. And so this magnetic field, as well as these balls of gas, sometimes interfere with our satellites or our technologies. And so what we do is we'll oftentimes turn our satellites away in order to protect them. But we will also still look at the sun. So if you look at this image up here, as well as the bottom right image, you will see two solar flares that just happened on November 1st and November 2nd. And so these are active solar flares that are happening. And because of this, and because they're pointed towards the Earth, we are able to see an aurora on the Earth, or there's a higher chance of seeing an aurora on the Earth. So if you live north of Arizona, make sure you check your area to see if that works for you. Oops, let me go back. Did that work? Yeah, there we go. So this beautiful image is, I believe, a photo that Rick took about 5 years ago in, Rick, help me out, I believe Yellowknife.
Yellowknife, Northwest Territories. So my wife and I flew up there. In fact, the next image that you showed, that's us standing there in our little parkas. Yeah. So if I remember correctly, this is 23 below zero. And we had little sort of warming tents that you could go into. But when the aurora happens, everybody starts yelling, and then they run out and they sort of see this thing. So this is really just like a part of that energy that Alicia was talking about. But the one that's hitting right now is big. I mean, this is a really big CME is what we call those, coronal mass ejections. So I think you've been reading about in the newspaper, and I wanted to just make sure we sort of put some context to it to see what's going on. So, thanks.
Absolutely. I photoshopped Rick and his wife on. I mean, this photo of Rick and his, no, they were really there. Or at least Rick took the time off to go there. I remember it. No, yeah. This is just a small glimpse of how absolutely beautiful it was. I'm sure this is just a photo, but in person,
it's spectacular. It really is.
Yeah, wonderful. And last but certainly not least, I'm sure many of you remember a few weeks ago when we talked about the launch of the Lucy mission. However, unfortunately, there have been some issues with some of the solar panels, or one of the solar panels, I should say. And so the good news is that the probe isn't in immediate danger. And so we just wanted you to be aware of this, that scientists are looking into it and are trying to decide what their next steps are. So keep your eyes and ears out for Lucy and all of our other current events. But with that, I think I'm going to pass it to Alex for resources this week.
Thank you, Alicia.
Thank you.
Thanks, Alicia. Yeah, we have some great resources for everyone this week. Let me pull them up and then share them for you. One of the first ones, this is kind of unrelated to James Webb. Well, everything's kind of related, but this is actually spaceweather.com. This is kind of a neat thing for understanding the Earth sun relation and all the weather that does. That includes solar flares, solar wind, auroras. So you can see there's a web page here. You can kind of get your quick view, and then you get a lot of additional
I see
stuff.
if there's sort of a headline about the CME we were just talking about.
Yeah, that's exactly it. So this is a great resource to catch yourself up and make sure that you know what's going on with some of the stuff that we've been talking about. So spaceweather.com, make sure to check that out. And then we have some more stuff related to James Webb. This is actually the main page for the James Webb Space Telescope. This is jwst.nasa.gov. This is just a great website to get activities, events, just general information for James Webb. And actually, one of our viewers pointed out that for our younger viewers, if anyone's here, there's some wonderful activities for young kids, and there's like a paper model and stuff that you can create. So be sure to check this out. This is another great resource, and those are our resources for the week.
This is going to generate a lot of excitement over the next couple of months. So I just want to make sure everybody knows. So I think I did the math before the program tonight. I think we're 46 days away, if I got that right. And so close enough. And so we'll see. We're all kind of like keeping our fingers crossed, and so hopefully that will work out. I wanted to just sort of give you some stuff going on in the near future. So on November the 13th, that's a Saturday. Our particular school has done annually for 15 or 20 years a thing called EC Day, Earth and Space Exploration Day. And usually that's on site, and usually that attracts thousands of people, and all people of all ages, and it's fun for kids, and it's all that kind of stuff. But we're still just kind of at the last parts of our COVID protocols. We are now open for business for students. Classroom is happening on ASU campus. All of our students are there, and they're engaged in their classrooms, and they're doing their education. We're not quite ready to open for big, huge public events yet, but we will be next year. This year on November the 13th, though, however, we will have a 3-hour program from 10 to 1. Do I have that right? Somebody will correct me if I'm wrong there. And it is a chance to sort of like, it's a chance to see, you'll hear a little bit more. You heard Rosalie and Tim and Alice talk about Rolf Janssen. He is also one of the specialists working on the James Webb Telescope. He's making sort of the keynote to this. He's kicking it off at 10 o'clock on November 13th. And then there are sessions and sessions and sessions talking about a lot of things that are going on at our school, not only in the space side, but in the geology side. And I will be hosting some segments in there. Alicia will be with us for part of that program. So Saturday, November 13th, right in the middle of the day, 10 to 1 EC Day. Our next virtual night sky will be on the 17th. And as you already heard, we're going to have to pick up back on the night sky and kind of just reintroduce some of that stuff and talk a little bit about the stars that we can see in the sky and those constellations that make up that beautiful story that I was kind of starting tonight. And then we'll have your emails. If you're on our list, we will definitely notify you of the activities that are going to go on with the space launch in December. And I want to thank everybody for joining us tonight. We've got a nice loyal following, and I know we get new people every day. So we're going to keep doing this as long as there's interest in doing this. And I can't wait to see you guys 2 weeks from today, on November the 17th, when we do our next version of the virtual night sky. Thank you very much, and we'll see you later.